Alright folks, welcome back. We're going to do worksheet number 8, identifying oxidized and reduced elements. Just a couple of things to remind you of. Oxidation is the loss of electrons and reduction is the gain of electrons. Or another way is that Leo the Lion says Gur. Loss of electrons is oxidation and gain of electrons is reduction. So we just need to do that. That's what we're doing here is we're going to be tracking electrons when we talk about oxidation and reduction reactions. Right. So just kind of going through this one with a little bit more detail, remember your rules is that when something is an element, it has no charge. And when something is an element like bromine, it has no charge. Now if I have something that goes from having no charge to being negative, right, that means it's gaining electrons. Right? And if I have something that's going from positive to having no charge, that all means that that's gaining electrons. Now if I'm going the opposite direction, I have to lose electrons. So if I'm going from a negative charge to no charge, or going to a positive charge, then what I'm doing is I'm losing electrons. So if I'm gaining, that's reduction. Reduction is the gain of electrons, and oxidation is the loss of electrons. So I'm not going to do that every time, but you need to do that. If you haven't written that down, go ahead and write that down. All right. Once we have something in a, in an equation, in a formula, right, something like aluminum bromide, it's bonded. Aluminum has a positive charge, a 3+ charge if you remember, and bromine has a negative charge. Right? So what's actually going on? Well, aluminum is going from no charge to being positive. So it has lost electrons. And bromine has gone from no charge to being negative, so it has gained electrons. So the thing that is oxidized is the thing that has, oxidation is the loss of electrons, so that's aluminum, and the thing that is reduced is bromine. Alright, so I'm going to do these a little bit faster. I'm not going to go and spend a lot of time doing that. Copper is positive, oxygen is negative, hydrogen has no charge. Copper, because it's an element, has no charge, hydrogen is positive, oxygen is negative. You'll notice that oxygen is negative both times, so that doesn't make a difference. So that doesn't change. But copper, on the other hand, is going from positive to being no charge. So it is gaining electrons. And hydrogen, on the other hand, is going from no charge to being positive, so it is losing electrons. So hydrogen is oxidized by OX. Oxygen is hydrogen, and the thing that is reduced is the copper. Okay, here hydrogen is positive, here hydrogen is negative, and here they both have no charge. So hydrogen clearly is gaining, and oxygen clearly is losing. So the thing that is oxidized is the thing that's losing, so that's oxygen. And the thing that is reduced is hydrogen. You say, oxygen is being oxidized. Yep, it is. Again, the definition doesn't necessarily make sense, the old definition. Our new definition is we're just tracking electrons and saying oxidation is the loss of electrons. And oxygen can potentially lose electrons. Alright, how about this one? Carbon has no charge when it's an element. Hydrogen on the right has no charge when it's an element. Hydrogen, when it's bonded with oxygen, positive, negative. And carbon and oxygen, remember, carbon can be either positive or negative because oxygen is negative, carbon is going to have to be positive. So carbon has lost electrons, so the thing that's oxidized is carbon. Hydrogen has gained electrons, so hydrogen has been reduced. And oxygen has remained negative in both cases, so it's a spectator, so it doesn't count. Number 5. Magnesium, positive, oxygen, negative. No charge for them as elements. Magnesium is gaining, and oxygen is losing. So oxygen is oxidized, and magnesium is reduced. Okay, how about magnesium chloride in this direction? Well, magnesium and chlorine both have no charge. And magnesium, when they're bonded, is positive, chlorine is negative. Magnesium is losing. Magnesium is losing, so it's oxidized. Chlorine is gaining, so it's reduced. All right, here oxygen is going to be negative, which means sulfur in this case has to be positive now. That does look unusual, but that is what happens. So they both have no charge over here, so sulfur is losing, and oxygen is gaining. So sulfur is oxidized, and oxygen is reduced. Okay, we're about halfway there. Hydrogen has no charge, chlorine has no charge. When they are bonded together, they're positive and negative. So hydrogen lost and chlorine gained. So hydrogen is oxidized and chlorine is reduced. Now, chlorine sometimes is reduced and sometimes oxidized, because when you reverse an equation, as we did here from an earlier one, back from number 6, you'll notice that everything reverses, because now magnesium is positive, chlorine is negative, and they have no charge on the right. So magnesium gained and chlorine lost. So chlorine was oxidized and magnesium was reduced, which is exactly the opposite of what we had back in number 6. All right. Well, here we have a single replacement reaction, positive, negative. Aluminum has no charge. However, when it's bonded with chlorine, it's positive, with chlorine being negative, and hydrogen has no charge. You'll notice chlorine is negative in both cases. That's the spectator. But hydrogen is gaining, and aluminum is losing. So aluminum is oxidized, and hydrogen is reduced. All right, how about this one? Well, mercury is going from being positive to no charge, and oxygen is going from negative to no charge. So the thing that's oxidized, the thing that loses, is oxygen, and the thing that gains is mercury. All right, how about this one? Copper, no charge. Silver, no charge. However, when they're bonded, silver's positive, nitrate's negative. Copper's positive, nitrate's negative. So copper is losing because it has to become positive, and to be reduced, nitrate remains the same. Silver must be gaining, which it is. Silver gains. All right, how about this one? Again, we remember that the carbon can be either positive or negative, but because oxygen is negative, carbon's going to be positive. Elements have no charge. Magnesium and oxygen, positive, negative. Oxidized, reduced. Oxidized is the loss of electrons, so who lost? Well, carbon gained and magnesium lost. So magnesium is oxidized and carbon is reduced. Oxygen doesn't change. Oxygen's negative in both cases. All right, now this was one of those red herrings where we kind of gave you a hard time with this one. This one's a tough one. So let's just think about the ammonium ion. If I look at just the ammonium ion over here, hydrogen is positive. That means nitrogen must be negative to offset it. If I look at the nitrite ion, which is over here, the nitrite ion, oxygen has to be negative, which means nitrogen has to be positive. So notice I've got one nitrogen on the left that's negative and one that's positive. And over here, nitrogen has no charge. Hydrogen's still positive, oxygen's still negative. So what's going on is one of the nitrogens, this nitrogen right here, which is going from negative to 0, it lost an electron. Well, where did it go? Well, this nitrogen over here, he gained it. So we have one nitrogen losing, one nitrogen gaining. So nitrogen is both oxidized and reduced because one of them was oxidized and one of them was reduced. I know that was a tough one. We figured we'd throw one kind of red herring in there just to mess you up. Okay, so that's it. If you have questions, please see us in class. We'll be happy to help. And if not,